Dear students, today we are going to learn the very important topic what type, what nature, what relationship does the current have with the EMF applied alternating EMF in a circuit for various type of circuits. Today we are going to talk about a purely resistive circuit, and we also assume for case of simplicity that the epoch is of the applied EMF is 0, means phase of the wave at the time t is equal to 0 is taken as 0. Here in this case we are considering a purely resistive circuit R, and across which we are applying some alternating EMF E0 sin omega t is the instantaneous value of the alternating EMF applied across the resistance. Well, you see where E0 is the peak value of the alternating EMF and omega t is the instantaneous phase. Omega is the angular speed and small t is the time lapsed. Here if we apply some EMF E is equal to E0 sin omega t across this resistance, and we call it equation number 1, then the current flowing through the resistance can be calculated by using the famous relation from Ohm's law, V is equal to IR, where V is the potential drop across the circuit, I is the current flowing through the circuit, and R is the resistance of the circuit. So using this relation we can have instantaneous current in the resistive circuit. We refer it as IR is equal to, you see I is equal to V by R, so we can write E0 sin omega t for applied EMF divided by resistance in the circuit capital R. Here you see E0 is constant. What is E0? E0 is the peak value of the applied EMF and R is the resistance of the circuit. E0 is constant, R is constant, so we can have another constant for this ratio. We call it I0, and I0 is nothing but the peak value of the instantaneous current flowing through this circuit, and we call it equation number 2. On comparing these two equations, expression for applied instantaneous EMF and expression for instantaneous current in the circuit, what we see that both are having the same phase omega t, and therefore we clearly see that both are having same phase. Current as well as applied EMF both are having same phase if this circuit is purely resistive. But in the topics which we are going to learn just after this one, we will see that this relationship both are having same phase, means instantaneous applied EMF and instantaneous current in the circuit are in same phase in case we are having a purely resistive circuit, means the ordinary resistance which follows the Ohm's law, and they are in same phase. But in other circuits we will see that they do not have this relation at all. They are having different phase relationship. Current and applied EMF are not in same phase, and that will find great many applications in our day-to-day life. So that's all for today. Thank you and have a nice day.